Everybody, welcome. I hope you enjoyed the first two speakers. I was in San Francisco with them 2 days ago, so that's why I missed it this morning. Our office is nearby, so I'm sure all of you know that. I'm sure because Richard Nichols, our technical director, this is his region, so I know he's very active. And so we're just nearby, and I was just catching up on some work. So I know what those, Professor Barfus and Doug Sargent have, told you guys, and basically the fact that the performance of PVC pipe is great. And this is based on really good, data. And I'm here to talk about the environmental profile of the product and the health and safety aspects as well. And this information, you have the reports with you, and I just wanted to highlight them quickly before I go through my slides. The LCA, life cycle analysis of PVC pipe, and sewer pipe as well, and comparative sustainability analysis of piping materials. So you've got this. This is a really good report, ISO certified. So I don't suggest, but I recommend you can look through it. It's lots of good information. Another one that we're going to talk about today is the Environmental Product Declaration, which comes with the LCA. So two of them are done together. Once the LCA is completed, then you do your EPD, and that's a full disclosure of the environmental impacts of PVC pipe. And then there's another one, which is a synthesis of all this material, called the Health, Safety, and Environmental Profile of Performance of PVC pipe. So I encourage you, if you have any questions or people have questions, you can just look in here. It's got all the key points that are out there in the market about our products. And we have about 30 references at the back that you can click on and get more information. So here we go. Thank you. So I'm going to start with the LCA of PVC pipe and PVCO. So just to give you an overview of sustainability, you're looking basically at two main sustainability factors: embodied energy and environmental impacts. And that's what you're going to try to do when you undertake one of these studies. And what is a sustainable piping product? So you've got to look at the various categories to help determine, what is sustainable. So when we worked with the practitioners in ISO, we came up with things like, longevity. Well, what is the expected longevity of piping materials? So we, looked at it from a 100-year perspective. Corrosion resistance is another factor. Luckily, that doesn't affect PVC pipe, but it affects other materials. And it is something to look at in terms of sustainability, because if your pipes are corroding, it's going to cost you more money. It's going to not be as sustainable as something that doesn't corrode. And then low, embodied energy, manufacturing. Is it recyclable? PVC pipe is recyclable into itself up to 8 times. That's when they stopped the studying of that. I'm sure it could continue. So you can take the pipe, recycle it, and make another one up to 8 times. But really, the key thing that you need to look at when you're evaluating the sustainability of different pipe materials is this part right here, the transparent disclosure of environmental impacts. And that's a really tricky one, because if you're not doing that properly, that's called greenwashing. And I'd like to, to tell everybody here and, to talk about the PVC Pipe Association. We're a neutral organization. Yes, the manufacturers pay our salaries, but we're a third-party organization. We don't make money selling pipe. We're just out there to work with research institutions, universities, as well as the engineers to help design PVC piping systems and provide the market with the appropriate information of our products. And so when we engaged the company, Sustainable Solutions Corporation, to undertake the LCA, they then ensured that it was compatible with ISO standards. So it's the same thing. Some people will say, well, your university, I can ask everyone, you've got your university degree. Did you pay for it? Well, you all did, right? Does that mean it's a corrupt degree? No, because the university had standards that they followed before they issued it to you. Same thing with LCAs. If you do it properly, it's not fake information, it's true information. And that's what I'd like to, let you all know. The information that you see there is unbiased information. So definitions, life cycle assessment, compiles and evaluates inputs, outputs, and potential environmental impacts of a product throughout its life cycle. And it provides, as I mentioned earlier, the basis for an EPD, the disclosure of that information afterwards. And then, it gives you some detail here, presents the quantified environmental information about a product over its life cycle. And we'll get more into that as I continue. So the other thing is going back to the standards that you need to undertake these things with. Here are the standards that were, used for the LCA when it was undertaken. So again, a company, did the work, but they were following all of these standards, and the standards organization had to certify it as well, just like with your university degree. So overview of sustainability. You break it all down: raw materials, transportation, then in manufacturing, transportation again, installation and use, and then transportation end of life. So these are the key things that you're looking at when you look at an LCA. Transparency and comparability. So that's the other thing, is if all the pipe materials did LCAs according to ISO, you'd be able to compare them all. But unfortunately, we're the only material in North America that's undertaken an LCA under ISO standards. And, interestingly too, ISO governs NSF International as well. So NSF International is governed by ISO standards. So it's the most rigorous standards in the world. And we find that frustrating because we have done that. We've disclosed our information fully with the most rigorous standards, and our competitors have not. And I'm not here to talk about against our competitors, just pointing out the facts. And then after the LCA, of course, the EPD. And then what we did with ours, we went even a step further. We did the LCA, and then we did the EPD under ISO. Then we got it certified by NSF International on top of that. So it's a very, very, thoroughly examined, EPD, and the information provided is very accurate. And then here's it gives examples of, what's inside the document. So you see there with the LCA, we had three people, independent reviewers of the LCA. That's part of the ISO process. They require that. So we had three experts look over the information on top of that. And then they certify it right here, as you can see, and then it's good. So this was the first one we did was 2015. And the one that you have now is a 2023 EPD. And the reason we're bringing it up to 2015 is because, again, that's what's interesting about these things. It's going to allow you to benchmark between, what happened in 2015 in terms of our environmental disclosures and what's going on today. Because, so again, transparency and comparability. So these are the folks, just another sort of a close-up of that original certification, and that's inside the document. And then you're looking at, again, it's kind of repetitive: product stage, construction, use stage, end of life. So all of these things. And then you've got maintenance, repair, replacement. So all of these factors, all the data has been put into this document to give a full picture of the environmental impacts. And then here are the products that were analyzed in the 2015 study. And they also did the same thing I'm going to talk about at the 2023 study. And so they looked at all of these and plugged the numbers and came up with these reports. What's interesting about the LCA is for water, you can see this. The first part here is cradle to gate. That's, manufacturing and installation right here in the orange. And then the green is use phase. And for water pipe, that tends to be, or it's going to be, the greatest impact segment of the life cycle of a pipe. And the reason for that is because it's accounting for pumping energy. And so you can see that PVC, because of its very smooth walls, it has lower pumping energy over time than HDPE. Now, HDPE they have smooth walls, but it's a smaller internal diameter. With ductile iron, well, what the study found was there's a degradation of the cement mortar lining over time. And because of that, over 100 years, you're going to pay a lot more money to pump water. And that's why typically when they design water systems with iron pipe, they put in bigger pumps to account for that decline over time in the efficiency inside of the water flow. And so here's, these are the kinds of numbers that are out there for the water pipe to allow you to compare the sustainability of the material. And of course, the use phase is very important to look at. The other thing too is, I don't know if we've left you a copy, but we're going to talk about it at the end. There's a lot of resources on our website. We just did a dig up as well as a field test of 42-year-old PVC water pipe and found out that the Hazen Williams was 155 to 160, and we typically recommend 150. So ductile iron will say 140, but it goes down, as the study showed, it goes down over time. We'll get to that in a second, but because they also did the larger pipe here too, and you can see the numbers again, PVC's performance versus the other products. So here was the slide I was going to talk about. There's the degradation over time of the internal walls of ductile iron pipe. So it decreases the efficiency. And there's a special study here on the hydraulic analysis between PVC and ductile iron. And the reason for that, I think as you've heard from Professor Barfus, those are the two main competing materials in the water market in the United States. So we put out a document because it allows customers to compare between the two main products used in the water systems. And there you go. Here are the numbers again. But that 140, so they start with 140, but it goes down with time. And interestingly, the ductile iron folks suggest that it stays at 140 for 100 years in all their documentation. And we just know that to not be true. And you can do your own research on it. But the LCA took into account that fact. So there's some graphs quickly on the difference in pumping costs with the different materials. And you can see again, PVC, PVCO are right in there in the best performing materials. And the other thing is, when you add it all up, the carbon footprint of ductile iron pipe is 6 to 9 times more than PVC. That's installation, use, manufacturing, all those things together. So really, we're the sustainable solution from a CO2 perspective. We're emitting the least amount. And then we get to gravity pipe. And the interesting thing here is that, PVC, again, on the profile side, it's not so commonly used, but let's say solid wall, the only comparative is concrete. Other than that, PVC has a much lower profile in terms of its CO2 and energy impacts. And then here, because of its smooth walls, look at you can use 21-inch basically for, that would be equivalent to paying for a 24-inch pipe. So you can go with a smaller pipe and get the same performance as you would with a 24-inch. And here's another thing in the study. They looked at a Purdue study on the environmental and health impacts of the various sewer pipe materials, and you can see ductile iron has the worst profile, PVC has the best. And this is a Purdue study that the LCA also included in the report. Now I'm going to get to I mentioned it earlier, 2023 study, APD. So, and then this time we included PVCO. The first one didn't include PVCO. But other than that, all the same sizes that you saw earlier, as well as the non-pressure pipe. So this is what really gets interesting from the health and safety disclosure, and this is why NSF certification of the EPD is so important. So it's saying all the things that are, important for utilities out there. No known chemicals are released into the ground and surface water during the use of the system. No known chemicals released internally into the water systems. No known environmental or health concerns associated in the manufacturing. No PFAS, and we just issued a tech brief on that. Did you all receive it? Maybe we could get your cards at the end, or maybe you can share them with Westlake, and we can put you on our database. We circulate this stuff regularly through our database to utilities. As well, no known microplastics are associated with PVC pipe. This is from NSF. And also no known extraordinary effects from water, fire, or wildfires. And we put that out because there's often claims made out there that wildfires are causing leaching of benzene from PVC pipe. Has anyone heard about that one? No, it's interesting. Oh, you did? That was, no, you're with Westlake. You heard about it. But yeah, interestingly, we talked about this in California, and no one heard about these things either. So maybe we're overly concerned about what our competitors say about us. I don't know, because no one here seems to be has heard about that either. But what the contention is that PVC pipe melts when there's wildfires and then leaches benzene into the water supply, which really doesn't make sense because the pipe's buried 3 feet underground. And there's tons of studies that show that the fire just goes over and doesn't, heat the ground enough underneath to melt the pipe or burn it. And what they found with all the utilities where they had wildfires is that they're continuing to use PVC pipe, and the PVC pipe in their systems worked perfectly during the wildfires. But what happened was the service lines attached to buildings, those burnt off from the wildfire and sucked in the benzene. And where's it coming from? It's coming from the trees. Trees emit all sorts of benzene from wildfires. That's your main source. But so anyhow, just sorry to get into the detail on that, but that's something that our competitors say about our products all the time. The other thing is minimizes environmental impacts due to the smooth surface of the inner pipe wall, reduces energy loss, installation. This gets into some of the details, but overall 6% reduction of embodied carbon and other environmental impacts from 2015 to 2023. So that's what was really fun about the EPD, is it allows us to benchmark what's going on in the industry. Inside the document, this is the older one, but it has the same kind of information that you can look at in the new one. And it's looking, we're using Tracy as well as CML modeling. These are all standard ways to express the information that they get from the material, to express it on, they have all these numbers here, and there's experts who know that stuff more than I do. But essentially what that says is that, so 8-inch, pipe, here's what you're looking at here. The top part is use, okay? And the bottom part here is manufacturing and all of that. And these are where the impacts are. Because with water pipe, the use is going to be your biggest impact area, because that's where the pumping energy is over 100 years. And here are the numbers that you look at. But the nice thing is, if our competitors did the same thing, then you could compare directly what this says to what they might be saying. But none of them have joined us in this endeavor. So EPD comparison, 2015 to 2023, electricity is the main driver of impacts, and it decreased by 20% from 2015 to 2023. Now, part of the reason we believe that happened is because the energy grids in North America have gotten greener with solar and wind injected into the system. So that allows our factories, or manufacturing plants rather, to use less energy, and in fact to continue using less energy as the grid gets greener. And so here's the other one, EPD comparison. So on average, there's a 6% reduction in impact categories across the board. So you can see it there. There's 2022 and 2015. That's when the data was analyzed, and then the report was issued in 2023. That's why it says 2022 there. But again, you can see all across the board the reductions, and we were very happy with that. And we're going to have to do another one in another 5 years, because they're only good for 5 years. But this again is good for the utilities. It allows you to look us up and see what we're up to with respect to the environment. And then of course now we add PVCO in here, PVC versus PVCO, and you can see PVCO is less across the board, generally speaking, than PVC, because there's less material in that product. It's a thinner wall, so it tends to be greener than normal PVC pipe, although both are exceptionally green. And then overall cradle to gate impacts, same thing. you see that PVCO is less across the board than PVC pipe. So I pointed out that document, I call it the the HSE, Health, Safety, and Environmental Performance Document. In there, we summarized all of the main points that are made against our material or positive things that our material can express. And so first thing is all ingredients are publicly listed and certified for use in drinking water systems by NSF. And this, you can go and look it up. It's all out there in the public. So when you hear that, well, there's PFAS in PVC, that was another claim that was made. And we put out a tech brief saying, well, it's not possible because there's no PFAS in our material ingredients manufacturing the pipe. So there can't be any coming out of it. And then another criticism would be, or claim, well, PFAS will leach through PVC if it's in the ground. And of course, that doesn't happen either because the bonds for the chemical bonds are much too large to get through the PVC bonds in the pipe. But anyway, this gives you all the information. I mentioned that. So microplastics, that's another interesting one. And because the claim is that PVC pipe is shedding microplastics as water goes through it. And really, microplastics are coming from the environment. Most of them are coming from tires, clothing, personal care products. That's where it's coming from. And then it's going into the water supply from there. The other thing we found out recently is paints as well. Paints have a lot of microplastics in them too. We're going to have to update that piece of information because it just come out in the last year that's another main source of microplastics. So you can see as we go through here, some other information. There's no toxic metals, no vinyl chloride release. So I don't know if have you heard about vinyl chloride? Anybody? You know, the derailment that happened in East Palestine with the train? That was resin, PVC resin, and they had a fire and stuff. Well, the claim is that PVC is leaching VCMs into the water supply. You cannot leach VCMs from PVC pipe because once it's polymerized, there's no VCMs in the pipe. VCMs are used to manufacture the resin. So again, we've got a tech brief on that. No phthalates, because phthalates are softeners for PVC, but the claim is made that PVC pipe leaches phthalates. It doesn't, it can't, it's not in there. Dioxin emissions. Every material, anytime you burn something, it's gonna release dioxins. And but guess what? Ductile iron pipe and cement release many more dioxins in the environment because they're using coal as their power source, as their energy source rather. And we use the electric grid, 400 degrees, I think, right, is the temperature, the maximum we use to extrude the pipe. So it's a low temperature, so very minimal amount of dioxins are emitted. And of course, the independent testing confirms that the material meets all North American water quality standards and regulations. And then there's a list here later. Well, of course, you've seen that one. PVC emissions are lower. PVC pipe has the lowest total embodied energy. It aligns with the key principles of the circular economy. Totally recyclable, I mentioned that earlier. Leakage and break rates are the lowest of all pipe materials. That's also a very good sustainability measure. PVC pipe has undergone the most rigorous and transparent environmental evaluation of all pipe materials. I mentioned that as well. And yeah, I like the term. It's climate friendly because it has the lowest CO2 emissions of any materials. And then here's just a small sampling of some of the organization standards, testing and certification organizations that tell you that PVC is a safe material. So there's lots of third-party validation for that. And in fact, I must say for all the pipe materials you buy, they're all safe in North America. I mean, because they all have to undergo, evaluation. So that is my presentation on environment, health, and safety.